Hi everyone, I'm Cheryl. In this problem, we're asked to find the curl of my vector function e to the x sine yi minus e to the x cosine j at the point 0, 0, 1. Now I know that the curl is defined as the cross product of that differential operator and my vector function. So I'm going to use a determinant form. I'll have vectors I, j, and k, the partial with respect to x, the partial with respect to y, and the partial with respect to z in that second row. And then the third row will be the components of my vector function. So this will be e to the x sine y minus e to the x cosine y and 0. All right, so finding the determinant. I begin with using vector I and taking the partial of 0 with respect to y. So that's the partial of 0 with respect to y minus the partial of minus e to the x cosine y with respect to z. So that's the partial of minus e to the x cosine y with respect to z. Then I have to subtract vector j. Eliminating the top row and the middle column, I'll have the partial of 0 with respect to x minus the partial of e to the x sine y with respect to z. Then I'm going to add in vector k times, eliminating the first row and the last column, this will be the partial of minus e to the x cosine y with respect to x minus the partial of e to the x sine y with respect to y. Okay. All right, so now I need to do these calculations. So I still have my vector I here. The partial of 0 with respect to y, that's just 0. The partial of this expression with respect to z, remember, if I'm taking the partial with respect to z, x and y's are both constants, so that's also going to be 0. I now subtract my vector j. I've got my partial of 0 with respect to x, that's 0 again. And here I'm going to have the partial of e to the x sine y with respect to z. Again, that's going to be 0. Then I'll add my vector k times the partial with respect to x. Now, remember that y is treated as a constant, so cosine of y will be a constant. And so when I take the partial of e to the x with respect to x, it's just e to the x. So I'm going to have a minus e to the x cosine y. Now I need to subtract what happens when I take the partial of e to the x sine y with respect to y. X is treated as a constant, so e to the x is a constant, so that'll be an e to the x. And the derivative of sine y is the derivative of the sine y is cosine y. All right, simplifying. I have 0 times I minus 0 times j minus, I'll have my vector k, e to the x cosine y minus e to the x cosine y, so that will be 2 e to the x cosine y. And normally we put the vector afterwards, so let's write that as minus 2 e to the x cosine y times my vector k. So that's the curl at any point. I'm interested in the curl at the point 0, 0, 1, so all I need to do then is plug in 0, 0, 1. So the curl of function f at 0, 0, 1 is going to be minus 2 e to the 0 cosine 0 times my vector k. Well, e to the 0 is 1, and the cosine of 0 is also 1. And so my curl is a minus 2 times my vector k. I hope that was helpful. Thanks.